Let's learn how to see the pattern, recognize the pattern that can be useful for change of variable or method of substitution, same thing. So the integral for the theorem for change of variable is as follows: f of g of x times g prime of x dx is equal f of u du, and it's equal f of u plus c. So this theorem representing undefined integral, but obviously we can use, and I did use in my previous video, I did use for definite integral also, because this method, change of variable or method of substitution, you can use it in undefined integrals as well as in definite integral. Okay, so I want to practice to see the pattern and figure out whether you can or you cannot apply or use this method. Okay, so we have example question number 1. I'm not going to solve it. Those are simple problems. I'm just going to help you to practice to identify where is g of x, where is f of g of x, and where is g prime of x. Okay, and accordingly make a decision. Okay, question number 1. You have integral 2x minus 1 dx. So this, let me move it here. I will have here f of g of x. Here I will have g of x. And here I will have g prime of x. All right, so f of g of x, it's going to be a square root 2x minus 1. G of x is going to be 2x minus 1. All right, and g prime of x, g prime of x is going to be 2, right? Now, here we don't have 2, but because 2 is a constant, we can easily fix it by multiplying and dividing, right, by 2. That would be very easy to fix. That would be a different story if we would have x additional or something else complicated. So this is, you can apply method of substitution or change of variable. Okay, next case, number 2. X times 2x minus 1. Integral x times 2x minus 1. So in this case, what do we have? Our f of g of x is going to be integral 2x minus 1. G of x is going to be again 2x minus 1. And g prime is going to be 2. Now, since you can ask, you have here x you can find out when you substitute u. So this x you can figure out from u and plug it here. Okay, because this g of x, it's the one, it's going to be your u, right? Let me put. This is the one that is going to be your u, and x you can find out from here and replace with u. right? So it's also possible case. Next one, number 3. Integral sine. Those are the pattern that not that clear, but then I will move to other cases. Sine squared 3x cosine 3x. Okay, here is what we are going to have. Since I have sine squared 3x, so my f of g of x is going to be sine squared 3x. Why it couldn't be cosine 3x? Hold on, I'm forgetting this dx is here. Why it wouldn't be f of g of x would be cosine 3x? Because you don't have their additional element, like here you have this square, see? Right? Therefore, the sine square 3x is going to be our f of g of x, and accordingly our g of x, which is going to be our u, change of variable, is going to be, let me see, sine 3x, right? Okay, and let me write down here u. And the g prime of x, it's going to be cosine 3x, right? And times 3, right? Because we have chain rule. Next one is going to be integral x over square root 2x minus 1 dx. Okay, we are thinking this way. So f of g of x is going to be square root 2x minus 1. Wow, funny, here everywhere we have square root minus 1. Let me put a different sign here. Put this as a plus and change on 5. Well, just to heck of it. It's the same thing anyway, but hold on. Okay, this is f of g of x. G of x is going to be obviously 2x plus 5, right? And it's going to be equal our u. And derivative is going to be 2, right? But here we have x again. This x you can find out from here. This x that we have, you can find out from here. All right? X will be equal what? U minus 5 divided by 2, the whole thing. Right? Okay. So we can do it. So you have to figure out if possible or not possible to substitute. Okay, next one. Now I'm going to bring example that you can clearly see. Also, number 5, we have integral f of 8x squared plus 1 times 16x dx. Okay, so f of g of x, it's going to be 8, here, there we go. It's going to be 8x squared plus 1 to power 2, right? G of x is going to be 8x squared plus 1, right? And the g prime, it's going to be what? Derivative, if I take derivative, it's going to be 16x, which we clearly have right here. Right? So you are looking 8x squared plus 1. It has some other here element of math operation. And if you take derivative of these parentheses, you get derivative written right here. So this such cases, it's eye-catching real quick. Next one, number 6. Let's say we have integral x squared square root x cubed plus 1 dx. So what we will have, f of g of x, it's going to be square root x cubed plus 1. And g of x, it's going to be x cubed without square root plus 1. And this will be our substitution. Okay. And the derivative is going to be free x squared. Very nice. So x squared we have here free. We can easily take care of it. Plus minus multiply, divide by, multiply by 3, divide multiply by 3 and 1/3, right? Okay. Another one, number 7. So we have tangent square x, secant square x dx. Right away I can see tangent as a gx, and square, tangent square will be f of g of x, and derivative of tangent x is secant square x. So it's easy to see some of them. So it's going to be f of g of x, it's going to be tangent square x. G of x is going to be tangent x. That's the one we are substituting. And lastly, a derivative is going to be secant square x. Okay, let's practice some problems here. Number 1, we have integral from 0 to pi over 6 cosine to power negative 3 to theta sine to theta d theta. And so what do we have? Our u is going to be cosine 2 theta, right? This is the g of x, correct? And cosine to power negative 3 is going to be f of g, right? Okay, and du is going to be equal negative 2 sine 2 theta. All right, and d theta. Okay, so from here we can say that negative 1/2 of du is equal sine 2 theta d theta. All right, now since we replaced it with du, so let's now change lower boundary and upper boundary that will match to a new changed variable u. Okay, so when theta is equal 0, right, because 0 to pi over 6, it's at our theta, and theta is equal pi over 6. So when theta is equal 0, then we are getting u is equal cosine 0, and that is equal 1. Okay, theta is equal pi over 6, u is equal cosine twice pi over 6, and u is equal 1/2, because we are getting pi over 3, and cosine of pi over 3 is 1/2. All right, let's now change it. And it is going to be from 1 to 1/2. Remember, in my previous videos, I mentioned it that when you switch, when you change the boundary or limits to a new one that will match to changed variable, it can happen that, hold on, it can happen that low limit or low boundary will be, the value of low boundary will be greater than value of upper the boundary. But because this is temporary, because that still means from 0 to pi over 6, there is no absolute need to change it, to switch it. Okay, so therefore we are going to keep it in the way it is. And it's going to be equal cosine to power negative 3. We are going to have u to power negative 3, right? And times negative 1/2 du, and this is going to be equal integral negative 1/2 comes out, negative 1/2 comes out, and here we are getting from 1 to 1/2, and u to negative 3 and du. Okay, and from here we are getting negative 1/2 and u to power negative 2. We're taking integral, so negative 3 plus 1 is negative 2, right? Over negative 2. And the upper and lower boundary, it's going to be 1 and 1/2. Okay, so this is going to be equal. So negative 1/2. Let's move negative sign of denominator, put in front of fraction. It's going to be 2u squared, yes, 1 and 1/2. So this is going to be equal negative 1/2 times negative 1, 2 times 1/2 to power 2 minus 1 over, minus, since we have negative 2, let me put it this way. I'll do this way. Negative 2 u, instead of u we have what this time? 1 times 1 to power 1/2. Okay, and we are going to get negative 1/2 negative 1 over 2 times 1/4, so which is going to be 1 and 2, and plus 1 over 2. All right, so let's see. Negative times negative, if we multiply this by this, we are getting positive, right? So 1 divided by 1/2, it's going to be 2, correct? This one here, this one, hold on, let me mark down this way. This is going to be equal to, right? Because we are doing 1 dividing by 1/2, it's going to be equal 1 times 2, right? Okay, and negative 1/2 times 2, it's going to be, well, positive already, negative, negative, positive, it's going to be 1. 1 and plus, well, this time it's going to be minus because I am multiplying negative 1/2 to positive 1/2, and it's going to be minus 1/4, and the answer is going to be 3/4. Okay, let's write down answer 3/4. Okay, that was number 1. Let's move to number 2, next one. So integral from pi to 3 pi over 2 Okay. Cotangent to power 5 theta over 6 secant square theta over 6 d theta. Here we are having interesting situation. We have cotangent and we have secant. Secant is a derivative of tangent and not cotangent. Therefore, I am recommending to take u as a tangent theta over 6 instead of cotangent because of this secant square, right? Let's see how far we will go with this. So u is equal tangent theta over 6. Okay, so from here du is going to be equal 1 over 6, right? Secant squared theta over 6 d theta, right? Okay, let me these two write down a little bit higher. All right, and from here, I wanted to put a signature. Let me do this way. So from here, I'm going to get 6 du is equal secant square theta over 6 d theta. So practically I just took this 6 multiplied by this du, right? Or you can take it as a brought to common denominator, whatever way you wanna take it. All right, so from here, now let's replace, if my theta is equal pi, what do I have? Then my u is equal tangent pi over 6. I'm using this u, right? Pi tangent equal pi over 6, right? Okay. So pi over 6, and it is equal 1/3. 1 over, square root 3. When theta is equal, we have 3 pi over 2, right? Upper boundary. Here it is. 3 pi over 2, then u from here is equal tangent pi over 4, right? We plug here, instead of theta, 3 pi over 2, and we get pi over 4, and that is equal 1. Okay, so from here, we are going to get integral so it's going to be, since it's a new boundary, I'm replacing from 1 over square root 3, and here is 1. Then we are going to get u to negative 5, and it's going to be 6 du, right? Here we have 6 du. Okay, this is going to be equal. Why we got this 6 du? Because what do we have here? Look, secant squared theta over 6 d theta. Here secant squared theta over 6 d theta. Yes? And from here, this is what we have. This is equal. Okay, well, might as well, we can take it already, the integral. And this is going to be 6 is coming out, right? And we have u to power -4 over -4, correct? Based on the rule of integration. Limit is going to be 1 over square root of 3 and 1. And this is going to be equal. So -3 over 2u to power 4. So -4, u to -4, I brought it down. And 6 and 4, I just reduced. And it's going to be 1 over square root 3. And this is 1. Let me this 4 write down smaller so it looks like u also. Okay, I think that's better. And this is equal -3 over 2. How much is at our u? It's 1. So we're plugging, first we're plugging 1, right? 1 to power 4 and minus -3 over 2, 1 over square root 3 to power 4. And what do we get from here? We are getting -3 over 2 plus 3 over 2. Now, how much is going to be this one? 1 over square root 3 to power 4. Let's see. Squared, it's going to be 3, right? So one more, because we have 2 of them, it's going to be 9, correct? And it's going to be 1 over 9, actually. So we multiply by 1 over 9. If you don't remember simple basic things, which can happen, so square root 3 to power 4, it's the same thing, square root 3 to power 4. So it's square root of 81, it is 9. Okay? All right, so we are getting here -3 over 2 plus 3 divided by 2 over 9, and which we get -3 over 2 plus 9 comes on the top, so 27 over 3, no, 27 over 2, pardon. Right? And we are getting -24 over 2. And the answer is actually positive. The answer is, let me clean it rather. And the answer is positive 12. Okay, moving to next one. Next one, let's take a different style of integral polynomial from 0 to 1, and we have y cubed plus 6y squared minus 12y plus 9 to power -1/2 times y squared plus 4y minus 4 dy. Okay. Let's see how we're going to solve this one. What we can do this time? So u I'm taking as, again, since I have negative 1/2 degree, so the polynomial under degree negative 1/2, it's going to be as a u. So we have u is equal y cubed plus 6y squared minus 12y plus 9. Okay, so from here, du is going to be equal 3y squared plus 12y minus 12. And I'm multiplying might as well, dy. All right, and from here, what do we have? So look, interesting here. Let me explain to you. Since we have g prime, right? This is our g prime, remember? Yeah, we have y squared plus 4y minus 4. Here we have 3 times more, right? I'm taking this 3 out. Three times y squared plus 4y minus 4, see? And I got g prime of y. Therefore, from here I will have 3 du is equal y squared plus 4y minus 4 dy. Okay, now let's take care of boundaries. We have from y at 0 to 1. So y is equal 0, and if I plug it here, right, then my y is going to be equal 9, because everywhere is going to be 0. And my y is equal 1, upper boundary. So lower boundary, upper boundary, y is equal 1, then u is going to be equal 4. Plug everywhere, subtract and add, you get u is equal 4. Okay, so we are ready to plug all these values we got. This is going to be equal integral from, let me put this one, from 9 to 4. So what do we have? This is going to be our u, right? Here we go. We are writing down our u to power negative half, right? And I have this expression here, which is going to be, if I have to squeeze in 3, right? Let's say squeeze here 3, because I need 3 du, right? This 3. And therefore I am taking out 1/3. Okay, and that will give me, let me clean this, that will give me du, right? Okay, let me clean this and this. And this is going to be equal what we are going to have, 1/3 to u to power 1/2, right? If you take that integrate, u to power negative 1/2 plus 1, it's going to be positive 1/2, right? And divided by positive 1/2, which is going to be 2u to power 1/2. Yes? Maybe I should write down. Times u to power negative 1/2 plus 1 and divided by 1/2. Okay, let me clean this. And I'm going to get So 9 and 4, and this is going to be equal 1/3 times u to power 1/2 and 2 comes on the top, obviously. And we are getting here boundaries 9 and 4. All right, so let's take care of it. This is equal 2/3, so we get 4 to power 1/2 minus 9 to power 1/2. Couldn't be easier solution. And we are getting 2/3 times what? 4 to power 1/2 is the square root of 4, right? It's going to be 2. Here it's going to be 3. It's going to be -1. And the answer is going to be -2/3. So the answer is -2/3. Okay, I hope this video helped you. You can feel comfortable enough to solve integrals with the method of substitution, especially for definite integrals, and post their questions if you have. Okie dokie. When theta is equal, we have 3 pi over 2, right? Upper boundary. Here it is. 3 pi over 2, then u from here is equal tangent pi over 4, right? We plug here, instead of theta, 3 pi over 2, and we get pi over 4, and that is equal 1. Okay, so from here, we are going to get integral so it's going to be, since it's a new boundary, I'm replacing from 1 over square root 3, and here is 1. Then we are going to get u to -5 and 6 du. Oops, let me write down nicer. Okay, I hope this video helped you. You can feel comfortable enough to solve integrals with the method of substitution, especially for definite integrals, and post their questions if you have. Okie dokie.